To solve some of the problems in the state of Texas, we're going to take several scientists working together, several scientists from different disciplines and different backgrounds and different areas of expertise, and who use different tools to solve those problems, to help us put it all together, to put the pieces to the puzzle and then find out what the problem really is and then see what the solution is.
One of the concerns we have with water quality is that a lot of our streams here in East Texas have been found by our local river authority or the TCEQ as not meeting their intended use criteria. In other words, they may have too much bacteria or something like this. So one of the things we're wanting to do at SFA is to work with the TCEQ and our river authorities and other local entities to start doing some monitoring and figuring out where these potential pollution sources may be coming from to improve the overall water quality in our East Texas region as well.
Well, water's our future. Land management is very important because it's our primary resource. We're monitoring the runoff off of gas wells. The SMZs are part of the best management practices for logging, and they provide protection for the stream against erosion and sedimentation. They also provide a barrier against the rest of the operation for herbicide application and fertilizer. And basically they protect the water before it makes it to the river. In Texas, it's adherence to the best management practices is optional as opposed to other states where it's mandatory. And Texas has better compliance with best management practices than states like Washington or Oregon. As of right now, the biggest impact that we've seen is just sediment runoff.
We only have about 25% of our bottomland hardwoods left. So if we plan on putting water on top of some of the things, we're going to even have less. And they perform such important ecological functions. We need to figure out a way to mesh increasing water supply with minimizing impacts to the bottomland hardwood.
What I'm doing is looking at large woody debris, is basically the logs within the rivers and the down trees, and just seeing, counting them and getting a number of how many are there and seeing how they affect the river.
And one of the things that we're doing with one of the faculty members in biology, Dr. Collier, is to develop a very good collection of fish species that occur in East Texas. There is not a current collection available as a reference collection, and he's establishing that. And that'll be useful for numerous studies that we intend to do in the future.
We're monitoring for several different chemical levels, and we will also be following sedimentation filling patterns. We collect water samples. Some of them are taken instantly in the field, others we gather in the lab, and we'll also be doing a GIS analysis, spatial analysis, to monitor the filling patterns through time.
We are looking to make sure that the wetland mitigation requirements are met by the county. They have to mitigate so many wetlands. So we put down these groundwater monitoring wells. We can then make an assumption of where the wetlands or how many acres have been created that would meet the wetland definition. We've put these lines all over around the lake, and we'll come back and sample them during the growing season to see if water's in them and at what elevation.
Water quality does change as the reservoir fills, and we don't have a great deal of knowledge about what changes do occur. We expect that there is going to be some elevated levels of organic matter, some color increase because of the vegetation that's going to be flooded. But that should clear up pretty quickly, and the water quality of this reservoir should be superior.
Water is a huge issue right now and will be an increasingly big issue, and the more we know about it, the more we'll know how to handle these issues in the future.